Okay, good morning or good afternoon, everyone. Welcome to the uh, today's lecture session. From today onwards, we will start with web security. Hope you had a good um, hacking with access control. From today onwards, we will look into the next module of web security. So we are diving uh, deep into the application oriented from today onwards. So this module will close by April 17th, and the next module lecture will start on April 16th, before the due date itself. So we will have a 3 days class for this lecture. I hope you had a good hacking for the access control. Let's start with web security. So from this web security, we are directly deal in the context of the application. Um, we just a second. Let me get to the slides. Yeah, so uh, in the modern world, almost all of the computation happens on the cloud and in the web technologies. All the services and the application, most of them are based upon the web applications, and the security and the credentiality of the application is crucial in this scenario in which most of the resources are from the web. And what we mean by web application? So any kind of applications that depends upon the networking web technology, in which the user will always be get connected, and in which the computation happens at the remote area, a remote place, that's we call a web application. So I just queried for any official explanation for the web application. Since it's evolved over the period of time, there is no something an agency that will provide you an official explanation for the web application. This is one of the good, when I asked ChatGPT, this is one of the definition that gave by ChatGPT, but it includes everything about the web application. It can be defined as an application which is not a standalone, because which can be accessed via web browser using network, and provide services to users involving databases and dynamic creation of the content. And the services can range from online banking and social media to e-commerce. Recently, I lost my iPhone, and it has been retrieved. It seems there are in US there are facilities in which if iPhone has been reported to be lost and they found it by some people, in which it is found to be not to be a genuine, like not resale, but if someone tries to sell in which the IME has been found to be not a new one, they would report and then they can trace to the original one. And they asked me to file a police report, and the police report also seems to be happening through online. So currently all services, email, all services and commercial transactions, retail purchase and everything happens through online, including the education. We have the pwn.college application learning through online. So this definition somehow clearly captures at least all the aspects of web application, in which the user is always connected and there is always a vulnerability of getting, always the chance of getting attacked if there is a vulnerability. And it involves complex systems and the dynamic generation of the content. And this also creates the more severe threat in the sense it can affect every users, and there is a chance that even a benign user can get affected because of getting connected to the applications. So It poses a real threat. Not a real threat, it's an immense threat, truly. And some of the cyber attacks that well known or that you might have heard from the news, the injection attack, cross-site reference forgery, typically in the case of banking applications, cross-site scripting, session hijacking, insecure direct object references, unvalidated redirect and forwards. We will go over the injection attacks, the cross-site scripting in your challenges, also CTF challenges, and some of the concepts that helps to avoid cross-site attacking. We call same origin and also the cause, that the same origin policy and the cause helps to prevent some of the potential risks that would happen from being, since every resources is able to connect to every other thing through web. Anything regarding question with regard to web applications? Yeah, so I would say the web application typically to be a client server architecture in which the application will be run in a remote place and the user will interact with the application using the browser, what we call user agent in our context, and it's called the client. The communication happens through voice, through networking. The voice is a reference model, TCP/IP, using the application protocol of HTTP. We've gone over all the HTTP in the talking web and also creating the web server module. So we should be already proficient with some of the terminologies that we will be talking over here. And OWASP is an organization, open, worldwide application security project, which gives more impactful and prominent threats based upon the history and also from the users or people. Once in every 4 years, I believe. So these are the top 10 security threats for the 2021. You can see here that the broken access control, cryptography seems to be the top first and second, which we have already gone over about what they are all about. And the third one is injection, deals with the web application. And this module we will be looking at in our next lecture session. And these are some of the top 10, and we will specifically look more into injection and related stuffs for this lecture. Probably something might also be covered. And you can see here the injection is the top one in 2017 and also in 2013. And in 2021, they merged the cross script injecting, where I can find, the 7th one, cross-site scripting, and a couple of other things, the XML external entities, and all the yellow one I think has been merged. I'm sorry, insecures, deserialization, the other things has been merged into a single thing of injection. Even though it moved down to the third one, it's still one of the top vulnerabilities, and 94% of the applications were tested to have presence of this kind of vulnerabilities that you can see from here. So the agenda for this module and for today's lecture, this module would be, we'll go over the introduction, and then we just introduced that web application is nothing but the interaction, the application running at the remote and the interaction happening through network. So we will go over the client side and server side technologies and languages, and what are the possible vulnerabilities that they create for the threat attacks. And then the next session we will go over the injection attacks, which is the third item for the threats attacks. And then on the last lecture, we will go over the topics on same origin policy and the cause, which allows for the resources to control even from the different origins. So that would be the agenda for this module. As we saw, the web application is about the applications running over the network, and we have the client and server in which the application runs on the server, and the user observes uses the application from the browser in the client area. So the server dynamically creates the web content and delivers to the server. The client receives this document in terms of web document and displays it to the user agent browser. So the content document is HTML documents. What is HTML? We already seen on the talking web about the protocols of the hypertext transfer protocol. It's it's encoded through HTML document. It's a markup language. So the documents would be in terms of HTML languages. It's a simple data format, basically a markup language. And we have the different versions starting from 4.3.2, 4.1. And then there was a major thing came on HTML5, but currently the standardization is a living standard, basically something maintained by the forum. If I remember correctly, the working group for this, which actively maintains the living standard of the HTML5. So it's currently the standard is a living standard, and it's a markup language in which you will use tags, hierarchical tags, to encode or markup with the documents. So you can see the HTML typical document will use tags with starting tags and ending tags. The ending tag would have the slash, and there can be tags without the self-closing. For example, here we saw the same tag foo that has to be closed using the end tag. There can be self-closing tag also that we see for bar to typically show the bar. There can be void tags also, in the sense there cannot be a specific tag to cover the content, like in the case of image, self-contained, I would say. Tags are hierarchical. So for example, the document would start with HTML and -HTML to show that this document is of the HTML type. And then we have the header that gives information about the documents and other things, other meta information that can be used up by the browsers. And then we have the body. So the P is the tag P is a paragraph. This is an example of paragraph that shows example. And the tags can have attributes that provide further metadata about the elements. So why we are going through this client-server application is nothing but the communications or transaction of these documents from the server and the client, and it can be dynamic. The client side also dynamically update the documents. Server will also dynamically send the document based upon the interaction between the client. So the attribute live inside the tag. The example of 4 different ways of providing the attributes in the document. So you can have within the tag itself, here the bar is an attribute, You can have the attribute with value. Here the bars is the value with quotation and other things. It can have multiple attributes. So if there are multiple attributes, it has to be separated using space. And then what's the web is all about? It's about the connected documents. So you are able to access from this document, this resource to some other resource, and you can embed other resource from other resource also, source also. So it's a connected documents. They are connected through hyperlink, and in HTML you will provide the hyperlink to other documents using the anchor tag. So A with the hyper reference. So this is the example. So the example would be the display shown on the web page rendered by the browser, and you have the color, something of blue color, and when you have clicked it would change to violet or red depending upon the settings of the browser. So this is the reference, the site that it will go using probably get command for the site Google. So and the browser will run the example as like this. So it shows blue. Once clicked, it will go into. I'm not able to click here. It will turn into some other thing to show that this site has already been visited. So this is the way to connect in the HTML. The doc type on the top refers to the type of the document. The typical HTML5 page. So as I mentioned, currently all of the applications, even if you have something, what do you think of? For example, you use a bot like Alexa. Even that bot, it seems to be self-contained, but actually it's always be connected with an application in the cloud, and it has to interact from the cloud application. So if it is a talking bot or even with the Zoom, I'm not sure any other application would work unless it first get connected to an account in the online. And it need not be the application need not be depend only upon the user agent for the desktop browser. It can be the mobile also, like in the case that it showed here. The HTML can be, the same document can be rendered instead of the commercial browser such as Firefox or Chrome, can be done through a console type of small application in your Linux desktop. Just you have to parse the markup and has to read the content. That's the idea behind here. The thing is that it should be connected, so the reference has to be retained, and so that's the basic thing. So this document has to be communicated or transacted between the server and client, and one document will link to every other document. It need not be from the same source. For example, you may be accessing the banking site, but it will have the reference or link to all other sites, which can be malicious also, and this poses a potential threat, and that would happen using the modification or injection in this document. So that's the basic thing that provides the platform for making a vulnerability to happen. So one of the other thing is that the HTML have the standard thing of this less than or greater than to use the tags for the markup. So how to display, if we want to display the tags that has been used for the special meanings in the HTML, so we have to encode it. So we will encode it using, so this we will call the named entity reference, and you will encode it using the and then either using a predefined name. So for example, in the case of lesser than and greater than that we use for tag, if you want to display it, you can use ampersand and less than LT and then semicolon. Or you can use the numeric character, Unicode character in decimal, or you have to you can use the hexadecimal prepended with the character X. And this also raises a potential risk, which you will go over later, in the sense of interpreting if there is a vulnerability in the applications that can interrupt the code into an HTML document. So this is also a potential risk of character encoding. And you would find that basically the potential happens if an user gets a chance to inject some of his code into the document and enable it to get displayed in the document itself. That's one of the common ways the vulnerability and the threat happens. So the character references uses the ampersand. So here we see the example of how to display ampersand. You can use AMP and AMP itself to display the ampersand. 38 is the decimal number in terms using decimal value of the Unicode, and X26 is the hexadecimal value, or 0026. It's E, acute E, there are 4 different ways of encoding it. So you can, the potential attacking thing, trying thing, you can use several different ways to see a vulnerability of encoding in the actual characters. This is the less than. So it has, so the first line y must encode just because it's one of the part of the special character with the meaning of using for tag. Yeah, so this is the basic thing of HTML. This is what the interaction of the basic thing that provided from the server and the client accessing, the displaying the content from the applications. So what threat issues happens? Anything, because of being connected and one thing is getting connected to every other thing, you have the potential of going have major impact. So for example, that's what you are seeing in the display here. The online applications happens to the web document, and when you click, for example, make a transaction, you get authenticated. What happens when you first open a banking site and getting authenticated? So what the HTTP is, so the question is the HTTP is stateless or stateful? Do you have any idea about those things? So it's a stateless. So to maintain the stateful nature of the transaction that's required for any kind of applications, you need to have some methodology to make it a stateful, and the cookies enables it. So the first thing that would happen after you visit the banking site and get authenticated, valid cookies would be created from the server. How do you remember how these cookies been set for the interaction, which we saw in Talking Web, I think? So how did the cookies created to create the state? So as per the HTTF, every transaction is a new transaction. It won't remember the previous state. The cookies help us to remember the previous state. It's created from the server. So the server, along with in the GET request, the server will in the header, the server would set cookie, and then create some cookie value, the browser would store up in the cookie, and then after the subsequent transaction, for every type of request, simple request, the cookies will get automatically attached by the user agent browser. So the cookies will always get attached automatically for every transaction to the same source. That's initially the server set it, and then it will get attached to it. So this is some of the, that shows the potential risk that happens, that we like to show here. So you are, for example, red, you get, for example, you transacted through the bank, and usually the transaction would be using, for example, using the get request, a bank transfer from, so the blue is the benign one or the actual one, and the red color is the malign one or attacker who wants money from the blue. So the request could be to, as simple as it, transfer the money from blue to red, the amount. It can get it done if it has the valid cookie. Ideally, not in the real world. So ideally, this should be, if the application, if you haven't any concern about the security, that should be the state. Usually, but it won't happen, because if it initiated from the red color one, it doesn't have the cookie because it is not a authenticated user. The blue is the authenticated user, and so it won't happen. So the blue is the authenticated one. The blue might have already logged into the bank, has the cookie stored in the browser, and it's actually active in the session. Do you know how long the session would be active? That can also be controlled through the cookies headers. It can save persistent, but for the applications such as the online banking, it will be active until the browser is closed. So the same cookie will not be valid after the session gets closed. So assume that the blue is already logged into the bank account and already active, and the red finds a way to get connected to the blue, and for example through email, and make it to visit to his site. It can be as simple as that, a kind of ad that's so prominent, or a kind of an email in which the blue PC, let's call the client A, doesn't need to open the email itself. There can be such that the image in which with the attribute something like, if you open the email itself, the get request will automatically get initiated. So when he clicks on curiosity, because of the curiosity of the image or because of the settings of the email itself, automatically get request can go to the red color, and the image. So this is how the interaction can happen, and there can be such that one of the image can be the interaction that can request the bank. The other click would be from the mail would be the interaction from the click would happen because the document is from the red. The image behind the image would be the hyperreference anchor would be this one, the bank transfer, the hyperreference. So the transaction, the get request would go step from the blue into the bank account with the cookie, because the click or request started from the blue. So whenever the request pertaining to the specific site started, since already blue is authenticated, the cookie is still active. So the cookie will get attached will be included into the get request, and so the bank, it's like a true transaction, it's a correct transaction, and so the bank would not find any difficulty in completing the transaction. So it can provide the response ideally, and so the response would be to close to the transaction and then the money get shifted. So the response would be to 200 OK, and then it could the money would get transacted. You can see because of being connected and the red being able to fish into the blue color client and make him to click, it's possible without considering the security and other kind of things to complete the transaction. But that won't happen really because of the steps and the security trunk that we will go over. One of them would be the same site origin policy, and the other kind of things that will prevent the response to get reached from the document of the red one, the document belonging to the red resource one, the other side. But you can see the vulnerability of how difficult it is once we get connected because of this thing. So it's important the data, arbitrary data, get transformed from one to another, and so we have to be like shown here in this book about the data being received from the client also. Like we saw, the data originates from the blue client by clicking the image, but it's actually malicious data originated belong from the red. So in the client side, so we haven't seen the HTML document. So these are the static elements that would be rendered from the HTML document. Those documents can also be controlled using the JavaScript. So as soon as HTML document is downloaded into the client and the browser start rendering it, it will create the DOM object, and the script can be used for rendering, dynamically render and modify the elements of the HTML documents. So the dynamicity at the client side is enabled using the script, and thus creates the potential risk also. And because the script can be from a different source, like we saw in the image, the image was from the different source, the initiating. So the image was belonging to the other side. It's not truly belonging to the banking side. And the script can automatically send request, collect information that has been already stored. For example, if not enough stuff has been taken, the cookies can be read by the script embedded in the mail sent from the red color client. So those are the things that has to be spoken about in terms of from the client side, because of the arbitrary data received from the server, remote servers, either benign like a banking site, or the malicious site from the red color remote other client that we saw. Same thing for the server also. It has to interact with all kind of users, and it can receive an arbitrary data from any kind of user, and one of the users input can be malicious, that typically damage the server and compromise the server. So the server has also should be spooky about the kind of interaction that's being received from the client, from the users, happening over the network from the other clients. So the security is crucial to ensure that none of the breaches can happen and compromise this secure, because of the arbitrary data happening over from remote to our client to the server, because of the connected world. And it's also crucial. So you have to embed from the third party, and you may not be assured of the authenticity of the data provided by the third party in your document. So the banking document, or you are a commercial site, you have to embed from the third party documents, and we cannot be assured of the data, arbitrary data that we will receive, we will send to the client. Any questions so far? Okay. I believe that this would be interesting in the sense if people from other than computer science working on it, this will give a real world context, and so somewhat seems to be interesting because a specific attack will have a well-known prominent threats that came as a news compared to some other attacks that would only knew by computer science experts. Even common people can know about potential threats that can happen, for example Uber or Amazon or some other things. So as I mentioned, for this today's lecture we will go over the first introduction and then the HTML and also about the SQL, and then for the subsequent section we will go for the next sessions we go over injection attack and then about the same origin policy and the CORS or cross-site scripting and other things on the last lecture. So we saw about the HTML document. HTML document is created by the server, but ultimately the client, the user has to see the client from the user agent like a browser. It's in the client side. The script can break havoc in the sense there is a potential vulnerability can happen because of the capacity of the script to do lot of things, asynchronous requests that it can make, and can ability to modify any part of the document using these scripts. So that's the client side that we are looked into. So for the web application that we saw, the web server also has to the session has been maintained using the client, and on the server side to keep track of the clients, it has to store the information persistently, and so it stores using databases, and it will also, so the client side you have the JavaScript, the scripts would be based upon the JavaScript languages. There will be a JavaScript engine run by the browser. On the server side we have I'm sorry. On the server side, we will store the state using databases. So we have to somewhere store so the application may not be possible unless you store data from the user or some sort of data for any kind of application. Not even, for example, user-oriented applications like online banking or commercial site. The storage of state and data is essential, and the server has to store the state or information, make it persistent, and it can done through memory, but how many can be stored in the memory? That's not possible. It can store as a file system, but accessing speed or concurrent access of the file, retrieving and thing of the file or the structure of the file like a flat or an XML file may not be appropriate in kind of the applications, but you can store as a flat file or XML type of documents for the information and the state, or else we can use database. That's what usually in the current one applications will do. That's the common for all the web applications. So the web application will use a database to store the states, user information, and whatever that has to be stored persistently. And why do we need database? It has its pros and cons. So one of the pros is AC ID. Anyone know ACID. So ACID complaints in the sense the storage has to be, the A stands for atomicity, consistency, isolation, and if I remember correctly, yeah, durability. In the sense, it should be reliable enough. The atomicity in the sense, like if there is a transaction, the transaction happens in 4 steps. If something breaks in the second step or third step, the transaction should not be complete. So assume that you have 1,000 and you have to increase it to 1,200. Before it has been increased to 1,200, if something stops and the $200 transaction has not been done, it should go back to the previous state. So the transaction should not be completed until all the steps has been completed. So all the steps of the transaction should be done as a single thing. That's the specification of atomicity. Consistency, it should be consistent. There should not be, for example, the data type or the rules for the change in data should be consistent. They should not change from one time to another or one data type to another data type. And isolation, so one type of transaction should not disturbing to other. It represents the concurrency also. So at a time, the single database, thousands of users can be user. So thousands of interaction has to be happen to the database, and one kind of transaction should not impact another. The second one, concurrency. So while looking at the pros, you can think about, you can compare it with the file system. If you are saving in a file system, you can't assure of ACID, or you can't assure of concurrency, or the separation of concerns. In the sense, the separation of concern mentions that the web application that you run, for example, in PHP, and then using the Apache server, that has something different from the database. You can move from PHP and Apache servers to mean stock, but instead of MongoDB, you can use the same database, structured database that you are using. And that's what we mentioned here. But there are some cons. One of them would be the cost compared to the file system, of course, and the complexity and the languages and the added new technology that we have to handle. So as we saw, the web application covers the whole kind of technology and other things, starting from the client to the server. And these are the typical model of the application for the application. So there would be a Linux server, and the Apache is the server that receives the communication, the HTTP request, and route it to the specific thing, and provide a dynamic web contact based upon the current request received from the client and the response being sent to the thing. That's the job of the server. And the MySQL represents the database. PHP is the server-side programming language that you manage the application. So you can see here, so these are the stack. You can have the different kind of stack also, but this is the most wide used and well-known or prominent stack web application model used widely. And as mentioned here, each component can be swapped. So you can swap PHP to Django or Flask. You can shift, for example, I'm not sure about that, to Windows. Of course, the Apache server can be switched, swapped to some other things, MySQL to Oracle. But this is the most widely used one. So the first one is the underlying server, the Apache is the server, MySQL is a database, and the fourth one is the language or framework that you use for managing in your server. MySQL is the database. Currently the second most open source database. What is the most used database if this is the second one? Any thoughts? Oracle, and I think Oracle is not the open source one. So it's first released on 1995. The Sun actually purchased it 2008, and then after Sun being brought by Oracle, it's also now the part of the Oracle. So the first most prominently used database would be the Oracle. Proprietary database, I think so. Probably there might be an online version also, I'm not sure about it. But we know Oracle is from the Oracle Corporation. So after Oracle bought MySQL, I think the open source version has been forked, and there's a MariaDB that people from the open source community use widely. But MySQL is the most widely second most used database, and it's a part of the LAMP stack. So what we see is that like the Java script and the script being part of the HTML document in the client side, and so it's essential to know about this, to know about the vulnerability, or if you want to make an attack or some other things. The database is the crucial part of the server, and database you will transact with the database or use the database using the as its own domain specific language called structure query language. What we mean by domain specific language? This is not a general language like C or C++ or Python. So the language only to transact with the admin of the server of the database. So that would be a client and server. So to query, you will make a query. The standard for making the queries and retrieve the data from the database server is through structured query language for the RDBMS. What's RDBMS? So we'll have a schema and the structure. So every data will be stored with already defined, well-defined structure and schema in terms typically of rows and columns and tables. And each entity will have the particular relation to the other one. And there will be a schema here, the structured languages. And this structured relational database is usually the data retrieved using the domain specific language called the structured query language. It's a standard, and so you need not worry about the type of databases. It would be almost same for any kind of database or DBMS. And you will have the commands, something like so. If you want to, the data would be in terms of rows and columns. The columns would be the specific type of data for the data interactions. Data would be stored in multiple tables, and you will retrieve specific. The rows would be the we call the specific data elements, and the language would be the specific data that has to be served as per the schema here. So the select one is the most used command. You can retrieve any kind of information for the specific user using the select command. You can update the data using the update command, and these are one of the insert one. So it's a language, and it doesn't have so much of thing. It's simple, and it provides it's flexible and powerful enough to retrieve any kind of data from the database by creating we call the SQL queries. So for example, this is one of the query. if you want to, for example, you have the transaction in pwn.college, in which already you would have a table, for example, user and their password. Now you have to create, for example, we create a new CTF. I think recently you have received a mail about quarterly new challenges opened. So we want to score, for example, the users along with their current scores for the particular quarterly challenges alone. You create a table, for example, here with the columns specifying the type of the information that you like to store for each user. So if there is some, even for simple sites, they ask to register the user, so they would be using a database. That's crucial essential. So if you think of a simple static website but has the option of storing the information, it will store the table something like this. It will have a column of username, password, and each row would represents the user. And so if you have to insert a new user who registers into your site, you can use the values here. So insert into the table name as a tuple of user name and password. So here the example can enter. And now here we're seeing about in the same select document from where. So the where helps us to introduce the conditions. So as you can see here, where username can admin provide us a way to filter and get a specific data from the database. What we call the row, I'm not used to call. So once again, sorry. Yeah, record. So if you want to use exactly as per the RBDMS, you can call it as a record. You can delete the user once he deregisters it, and you can also update it. So for a specific information, what we call as a column, for a specific user or record. So for example here, it updates only the password and for the specific user key, user for example corner. And there can be, so the multiple tables, you will have something called a primary key, and that would be a common across all the tables. And using those kind of thing, you will query information or columns from multiple tables using the where clauses, and then you will retract any kind of specific data for a specific record that you want. So this is and there's a thing called union SQL command. So you can retrieve two different columns and then union it and then make it to retrieve in as a single column. And as you will see, it's also an important thing that plays a crucial thing in security also. We call union vulnerability. So this is also one of the things that you have to pay attention. But the union clause in the SQL typically can able to use two different select thing and then retrieve it as a single column. So you can have two different selects. And then you retrieve it, the query will be returned as a single column. But the thing is that both of the columns should be of the same data type. That has to be ensured, and it has its own potential risk that you will learn in the challenges or from the later. And this is one of the thing of selecting schema that shows the what are the tables for that schema implemented. You can drop table also. So as an attack, for example, if it's rolled as a root, and there is a possibility of using the user as a SQL command, and if there is a drop table, it's actually delete the tables. So for example, for this table of user and password, the drop table will delete the user and password completely. So why we learn this SQL is SQL is the essential and important thing that is required for all the web application in the server side. So this has to be all the transaction that you do in the HTML document will have the aspect of saving it in the database or retrieving information in the database, and so it produces some of the means to be able to find some open door or vulnerability in the application that can provide a backdoor for something to access the database and create kind of attack in the database. So that's why we are learning about the SQL, which is one of the important ways for, and in the injection command we will learn about the SQL injection. So we can insert prominent kind of injection. We can injection. So we have something called a code injection. So the HTML document is also run by the browser and render it using the script. And if it contains a code or the HTML encoded, it can be, instead of the user code, it can be rendered as a HTML document. For example, a link that can be clicked by another user, and behind it can be actually referring to a link. So if the user input, they can encode something of a HTML type or a script that raises a potential risk. Similarly, in the case of server side also, if a user can able to store something into the server side, and the server side will be storing in the database, and if you can able to breach some of the things in the database, that creates a potential risk and the vulnerability. And so the thing has to be taken care of when storing the information that we retrieved from the user. You can know, so the SQL injection is the most prominent one, which we will use it in the challenges. For our challenges also, you will learn about the things that can happen if not enough care is taken while processing the user input for the SQL queries. Any questions so far? Yeah, we are not concerned about the PHP or the server-side language or Apache, but whatever the interaction that happens, it's going to get stored in the database. So it's one of the potential opening to make an attack, and we know that the language is SQL, independent of any kind of database that they are using, Oracle or any other kind. So it has the specific case of SQL injection happens because of the compromised application that can store malicious data into the database. For good resources, you can refer Mozilla Developer Network, which gives very good information about the HTTP and other kind of web information related protocols. It's a man page of man page for web documents and for HTTP. And the information about the threats and the attacks, you can, the top 10 that we discussed for the OWASP, Open Worldwide Application Security Project, they provide some more information about, also about the threats and also about some other open projects that we can be involved with and interested in. And if you're not prominent with the query language in case, or JavaScript or MySQL, SQL query languages, you can use the W3 SQL. I find it to be useful. I'm not sure about other you guys, but it's somewhat good. You can use it. Any queries? Yeah. So next we will go over the threads. That's the agenda would be for the next week. We can go over the threads, and then for the on the next week we will look at the other kind of like same origin policy and the cross script injection attacks and the calls in which the ability to interact with, make requests and respond with the other sides. Any queries? If there is no queries, we can, yeah. Thank you for information. I think there is no queries from the online also. If it is, let me know. Yeah, otherwise we can close. Thank you all.